to the next tutorial in biostatistics. In this tutorial, I'll be talking about measures of dispersion. In statistics, dispersion is usually or commonly used to explain the scatter, deviation, fluctuation, spread or variability of a data. And dispersion is used to denote the lack of uniformity in the item values of a given variable. Now, let's see what dispersion is. The degree to which the individual values of the variate scatter away from the average or central values is called dispersion. We have learned in measures of central tendency that some of the values, or if you have a set of values, some values will be concentrating around the average or the central value. That was measures of central tendency. And the measures of dispersion is just opposite to the measures of central tendency. It explains the deviation of the variable from the central value. The deviation of the variables from the central value is called dispersion or measures of dispersion. So it is a degree to which the individual values of the variates scatter away from the average. This is the average. Measures to which it scatter away from the average is called dispersion. Then the measures of dispersion is one of the most important tools of statistics, which has got very important application in case of biological data. For example, in the biological data or biological observations, we can see the length or the height, weight or the RBC number of two individuals. The number of RBC, weight or height of individuals of the same species, of same age and same sex will vary. It is different even if it is the same species. Then another example, in the case of plants, you can see the same plant of pea. A pea plant produces, the same plant produces different number of seeds in different pots. That's also different data. Then same person exhibit different pulse rate and heartbeat in different physiological condition. The people with same age of the same species and same age and sex will vary. So the measures of dispersion has got very important application in case of in handling the biological data. Now let's see what are the different types of measures of the variation or measures of deviation. The measures of deviation is of 5 types: range, quartile deviation, mean deviation, standard deviation and variance. And in this tutorial, we'll discuss something about, I'll be talking about range and mean deviation. Now let's see what range is. What range is. Range, as the name signifies, from the name itself, you can say what. So range of distribution or raw data is the difference between the maximum value and the minimum value of the observation in the data, or R is equal to L minus S, where R is range, L is the largest value of the variable and S is the smallest value of the variable. And let's see how we can calculate or how we compute the range of individual series, discrete series and continuous series. First is computation of range in the individual series. Let's see a question which is given here, which shows the number of earthworms in a plot, and from this data, if the question is given here, the first step what you have to do is arrange the data from the smaller value to the largest one. And from this question, the largest value range is L minus S, and after arranging the data like this, which is shown here, the largest value is 506 and the smallest value is 416. So So range is equal to L minus S or 5 or 506 minus 16, it comes to 90. So that is the range of the individual series. And now let's see how we can compute the range of discrete series. And this is an example which shows the number of seeds per plant in the of black gram. And here you can see the number and seeds and number of plants. And in this question, the largest value or L is equal to 75 and the smallest value is 15. Smallest value of the variable, it is 15. So 75 minus 15, it comes to 60. That is the range of this question. Or range of, this is a range, this is how you calculate the range of discrete series. Now let's see a range of continuous series in which class intervals are coming. And then this is a question which shows the range of the number of seeds in plants. And here in such question, what you have to do is in the questions in which the class intervals are coming, the lowest value will be the lower limit of the smallest value will be the lower limit of the first class or the lowest class. And in this question, the lower limit of the first class is 11. So is equal to 11, and the largest value of the final or the last class interval is the upper limit of the last class interval is 80. So L is equal to 80. In the questions in which the class intervals or for continuous series, S is the lower limit of the first class and L is the upper limit of the last class. And so in this question, L is equal to 11 and L is equal to largest value is 80 and S is equal to 11. So range is equal to 80 minus 11, that comes to 69, and that is how we calculate range. So range is R is equal to L minus S, where L is the largest value of the observation and S is the smallest value of the observation. Now let's see what mean deviation is. Mean deviation. Deviation, as the name signifies, the mean deviation is the average of the absolute values of the deviation from the mean. Deviation, as the name signifies, it's the value of, is the average of the absolute values of the deviation. I said earlier, deviation from the central value, and each variate of the variable deviates from the mean. And if this is the mean, if this is the mean value of an observation or average of an observation, values, the other values in the observation will scatter or deviate from the mean. That's known as mean deviation. And these values will either scatter above or below the average, and the deviation above the mean is called negative deviation. This is above means from this side. For example, if the deviation mean is 5 and this is 3, 1 and all, this is known as negative deviation. The values which deviate above or the values which is in front of the mean is called negative deviation, and those which are below the mean is called, this side it is positive deviation. So deviation deviation which is below the mean or towards the positive side is called positive deviation. The deviation towards the negative side is called negative deviation. And mean deviation is denoted by delta. Mean deviation is denoted by delta. And now let's see the equations for deviation. And first let's see how we calculate the mean deviation of ungrouped data or individual series. Calculate the mean deviation. Delta is equal to sigma d, that is d, and here we use two lines which signifies the absolute value. And here these two lines, when you use two lines, and for again I am explaining for this biology students, and if you are having a negative value, -3, if you put two lines like that, that's equal to 3 only, because when we put two lines on either side of the number, negative or positive, you have to ignore the signs, whether it's negative or positive. If it is +3 and you are putting like this, it is simply you can write 3, or it's positive itself. For -4, it is 4. For -1 is equal to 1 itself. So if we put two lines on either side, that means you have to ignore the sign, whether it's positive or negative. Now the equation is mean deviation delta is equal to sigma d, absolute values, divided by, that is n. Then d is the deviation from the actual mean. D is the deviation of the actual mean and n is the number of observations. And now let's see how you calculate this deviation. So deviation means deviation away from the average or the mean value. So deviation or D is equal to score or the value of the variable minus x bar. X bar means mean. So D is equal to x minus x bar. This first step is calculate the mean, our arithmetic mean, then calculate the deviation, then apply these two values in this equation. So the different steps for computing the mean deviation is, first step is to calculate the first mean. First step is calculating the mean of the data which is given, arithmetic mean of the data which is given. Then calculate the deviations. Deviation is equal to x minus, that is the variable, value of the variable, minus the arithmetic mean. N is the total number of items and divide it by total number of items. Let's see, work out a question which is given here, which shows this is an ungrouped data, and in this step the x which is laid by a number of x laid by a species of bird is given here. And the first step here is, as I said, first step is calculate the mean. So arithmetic mean x bar. When you get a question like this, the first step is to calculate the arithmetic mean. Arithmetic mean is sigma x by n. So in this question, sigma x is equal to 5 plus 7 plus 8 plus 10 plus 14 plus 12 plus 13 plus 7 plus 8 plus 8 divided by total number of observation is 10. So 90 divided by 10, that's equal to 9. So 9 is the arithmetic mean for the data which is given here. That's the first step. Step 1, calculate the mean or arithmetic mean. Second step, prepare a table with 3 columns which shows to obtain the value of the deviation. In the first, you can see here the table is shown here, and you can write here score, then the score minus mean, which is that is how we find the deviation. score minus mean. Mean we have already calculated, it is 9. Then third, here in the third row, you have to write the deviation. And the first column, it is 5, 7, 8, then comes to 10, 14, then 12, 13, 12, 13, 5, 8 and 8. And in each step what you have to do is score. This is the score or the value of the variable which is given here in the data. And the next column here, what you have to do is to subtract. That is here score 5 minus 9. This column score is 7. So 7 minus 9. Here score is 8. 8 minus 9. 9 is the arithmetic mean which we have already calculated. Then likewise 10 minus 9 and go on. You have to complete the table. It's shown here. And here this is what is deviation. And the answer for this is 5 minus 9 comes to minus 4. 7 minus 9 comes to minus 2 or negative 2. 8 minus 9 negative 1. And the next step is to complete the table shown here. The completed table is shown here. And the next step is to calculate the absolute value of deviations. Sigma absolute value. Absolute value means you have to take, this is the deviation. We have calculated deviation for each variable. And for finding sigma d, what you have to do is you have to ignore the values. If you put two lines, I said if you are putting two lines on either side, negative 4 plus absolute value of negative 2 means it is simply 4 plus 2. Absolute value of negative 4 plus negative 2 means it's simply 4 plus 2. You have to ignore the values. So sigma d is equal to 4 plus 2 plus 1 plus 1 plus 1 plus 5 plus 3, and it comes to 26. Sigma d or deviation is 26. And now next step is mean deviation is delta is equal to sigma, the absolute value of deviations, divided by n, which is the total number of observations. That comes to delta is equal to 26. So delta or mean deviation is equal to 26 divided by 10. That comes to 2.6 is the deviation for this question. Now let's see how we find the mean deviation for group data or discrete series. For group data, the equation which we use is, group data will be having frequency. So delta or mean deviation is equal to sigma, absolute value of FD, divided by sigma F. This is the equation which is used to find the mean deviation of group data, and sigma FD is the sum of multiplication of frequency with frequency and deviation of each variable. F stands for frequency, D stands for deviation of each variable, and here F stands for frequency. And the two lines on either side means you have to ignore the value, or ignore the sign, whether it's negative or positive. Now, the different steps to find the mean deviation of this discrete series is, the first step is, of course, calculate the mean. First step, you have to calculate mean or x bar. Then calculate the deviations from the mean, ignoring the signs, and denote them by D. Then multiply F with D and divide sigma FD divided by with sigma F. Now let's work out a question. The question is given here, which shows the length of 50 beetles of a given species. And from this question, first step is, I told you, you have to find the mean. And before finding the mean, let's make a table. That would be easy. Table with 5 columns. We can first make a table with 5 columns, which shows the variable, frequency. Then you can have a column for frequency into x. Shown here the table, that is deviation is equal to variable or x minus mean, then absolute value of f and d. So you have to complete this column with the question, variable in the first column, frequency in the second. Then you have to calculate f into x, or f into x means 2 into 2 gives 4. Then deviation is shown here. Deviation is x minus mean. So after completing this table with f until fx, you can calculate the mean using the equation x bar is equal to sigma fx by sigma f. Sigma fx by sigma f. And from this table you can find the value of sigma fx as sigma fx is equal to 231.1. Then sigma f is 50 beetles. Then so x bar or arithmetic mean is equal to 4.62. Then complete the next part of the table, that is deviation part. Deviation is equal to score or x minus mean, and complete the table with by subtracting 2 minus 4, then 2.5 minus the mean, then compute the f into d. And while computing f into d, it's shown here on the table on either sides of fd, 2 lines are put, that is absolute value, or you can ignore the values, or ignore whether it's positive or negative. Then the table is completed. Now you have to find which we have already prepared, deviation. We have computed the sigma fd, that is table f, which we have deviation or delta, and which we have already found the sigma fd, that is by sigma f. Deviation or delta or mean deviation is 59.46 by sigma f, and here divided by sigma f is 59.46, and the value comes to 1 divided by sigma f is 50. This is the mean value comes deviation. To this is how we find the mean deviation. 1. Now let's work out another question. Let's see how we find the mean deviation of continuous series. This case the same formula, that is sigma. Let's see how to find the mean deviation of continuous class interval in the continuous series. We have to find the midpoints, because class intervals are there. We'll find the midpoints. So the question is given here. Find out the mean deviation for the given data. You have the class interval and the frequency. So the first step is to prepare a column with a table with 6 columns. First step, prepare a table with 6 columns, which shows the class interval, then the midpoints. This is only difference from the other table. You have to calculate the midpoint, and the midpoint is x. Midpoint is, value of midpoint is taken as x. Then frequency f, then f into x, then you have to calculate the deviation, then f into d. These are the 6 columns, and from this column the table is shown here. You have for 2 to 2.9, the mid value comes to 2.45, and the frequency is 6. So f into f into x is equal to 2.45 into 6. That is equal to 14.7. Then you have to complete the column, find the value for sigma. The step is to calculate the mean, or mean is equal to sigma fx. Sigma fx by sigma f. That is equal to 229.5 divided by 50. So mean value is 4.59, and here the deviation we calculate by subtraction, and we get the deviation is minus 2.14 for the first value, or delta is equal to sigma fd, the absolute value of sigma fd divided by sigma f, that is equal to 1.168. 1.168. So in all the questions, this is how we calculate the value for how we compute the mean deviation of a continuous series. So while finding the deviation, the first step of course is to calculate the arithmetic mean of the data, whether it is continuous, discrete or individual series, because we have to subtract mean from the deviation is equal to score, or the value of the variable, minus mean. That is the important step. Then we have to find frequency into deviation before finding the answer. And now coming to the merits and demerits, values are ignored. It is rarely applied in biological sciences, and because it is the values are being ignored, it is having not that so meaningful. And thank you.